Hi there, trig guys. So we're making pretty good progress into our understanding of trigonometry. One of the things that we have seen is a lot of identities have been proven. And what we're going to do now is using those identities, we're going to try to show how we can prove new identities are also true. So remember, an identity isn't an equation. An identity is something that is true for all values of x. So for example, here is a very simple identity. And this is true for every single value of x. It's not an equation, well, it's sort of an equation, but the result is that all reals satisfy this. And we indicate that something is an identity, if you remember, by using 3 lines. And that shows that it's not an equation, but an identity. So let me make a list. It'll be an incomplete list, but let me make a list of the important identities that you have studied so far. So the first category are what we call the Pythagorean identities. And this should be familiar to you. We know that sine squared of x plus cos squared of x will always equal 1. And if we divide everything by cos squared, we get a similar identity. Tan squared of x plus 1 equals sec squared of x. So those are the major Pythagorean identities. Next, although we haven't proven it in these lectures, you should have learned by now the sum and difference formulas. And I'll just save some time, I'll just write them down right now, but they should be identities that you are familiar with. So here you go, they'll appear immediately. So here's our first one, and we're really putting in 2 identities here in one. The first one is that the sine of a plus b is sine a cos b plus sine b cos a. The second one is sine of a minus b, and we just follow it through again and use the minus sign there. Okay, let's look at what cosine is. Alright, so here are the sort of 2 formulas for cosine. Here's the plus, and we follow it through, and this is a minus. If it's cos of a minus b, then this sign is a plus. Alright, and we have one more set of identities, and they really are just special cases of these 2, where a and b are exactly the same. It looks like this. So the double angle formula for sine, and just imagine that instead of a we have x, instead of b we have x, and 2x is a plus b. So you're going to get sine x cos x plus sine x cos x, or 2 times sine x cos x. Same thing for the cos of 2x. We just go back up to our cosine here, and we let a be x and b be x, and we're looking at the plus. So we get cos x, or cos squared x, minus sine x, or sine squared x. So those are our big identities, and we'll use those in terms of proving new identities. Alright, so I think the best way to help you understand how to work with proving identities is to look at some examples. And before you do that, I suggest that you read these guidelines that I have written here and try to make sense of them, and as I go through the examples, I'll refer back to these. Okay, here we go. Alright, so here's an identity, and we want to try to establish it. In other words, show that this is a statement that is true for all values of x. And although it doesn't always come up, it's sometimes a good idea to take the expressions that you have and write them in terms of sine and cosine. So I'm not sure which side looks more complicated here, but we'll work on both sides separately. And it's going to look like this. Tan of x is sine of x over cos of x. plus cotan is cosine over sine. Close enough. Okay, and secant is 1 over cosine, and cosecant is 1 over sine. Alright, so that's what I mean by working on each side separately, and that's what this line down the middle helps us remember. So now, we're going to look at this statement, and your instinct hopefully should be, let's get a common denominator and add these together. And if we do that, the common denominator is going to be cos of x times sine of x. And so what that means is this gets multiplied by sine, and this gets multiplied by cosine. And do you see what we're going to get? At the top we have sine squared of x plus cos squared of x. And this is important because right here we already know that that thing is the same as 1. And so if I follow this down just a little bit more, I'm going to get 1 over cos x times sine of x. And that really is the same as what we get over here if we multiply this out. So what you see is that each side is identical, and essentially we have proven that identity. We have shown that that statement is true for all values of x, because this side and this side are identical. And that's what an identity means. Alright? Okay, let's try one other one. Okay, so here's one that we're trying to prove. And there's always a lot of, well, not a lot, but there are some tricks that pop up a bit. And if you look at this expression, what we're going to do is change this a little bit. And we're going to take cos of t over 1 minus sine of t, and we're going to multiply top and bottom by what I like to call a clever form of 1, which is 1 plus sine t times 1 plus sine t. Right? So when we do that, let's just leave the top kind of multiplied out. We're going to get cos of t times 1 plus sine of t. And on the bottom, what do we get? Well, 1 minus sine t times 1 plus sine t simplifies to 1 minus sine squared of t. And what does 1 minus sine squared of t equal? Remember your Pythagorean identities? Here's what we get. We get cos of t times 1 plus sine of t all over cos squared of t. And so what happens here is we can cancel out one of these cos t's with one of these cos t's, and what we have is 1 plus sine t over cos t, which is exactly the same as that. And so essentially we have established that identities. So, there's no set rule, there's no that's a lot of times students will say, well, what's the rule, what's the algorithm for solving identities? And there really is no one rule. And that's kind of cool because a lot of students can approach an identity like the one we just did and perhaps work on it differently. Perhaps they would have multiplied this top by 1 minus sine, this whole fraction by 1 minus sine t over 1 minus sine t, and things would have worked out that way too. So lots of ways to prove identities, and as long as what you're doing is legitimate, and as long as you're appealing to known identities, you'll probably get there. So have fun with them. It's one of the more creative things that you do in trig. Catch you next time. Ciao.